Here I'm going to demonstrate how to numerically solve the mass balances that result for a series reaction in an isothermal batch reactor. I'm going to use PolyMath to carry out the solution. So the first mass balance, the derivative concentration of component A respect to time, equal to the rate constant times the concentration of A. And then B is involved in two reactions, so we're forming B in the first reaction, so there's a plus sign here, and then we're removing the second reaction. It's an initial value problem, meaning we know the concentrations of A and B at the beginning. Ca is equal to 10 at time equals 0, and Cb is equal to 3. We're given the rate constant, and we want to integrate from time equals 0 to time equals 8. This is dimensionless for sake of demonstrating use of PolyMath. So let's look at the PolyMath program, in this case PolymathPlus, to see how we solve these equations. So I'm going to go into Edit and pick a larger font just to make it easier to see in the screencast. So the way we enter a differential equation for the mass balance is putting the variable concentration of A inside parentheses, and likewise putting time. So we're entering pretty much the way the equation appears on the left side here. So we have a minus K1, and star is multiplication, the concentration of A. And then we enter the initial conditions for A. Notice there's no subscripts or superscripts in these PolyMath equations. I can enter a comment by using the number sign and writing mass balance for component A. Well, I can likewise do the same thing for the second differential equation, second mass balance. But let me pause and just type that in. So, two terms in the differential equation on the right side. The only difference is this is how we do raising concentration of B to the second power. The only other things we need are the rate constants, so we have to enter 0.45 and K2 equals 0.50. Now we have to tell PolyMath where to start the integration, so T, this means the starting point, in this case time equals 0, and then the finals, we use F for the final, in this case it's 8. So now we have everything we need to solve these two mass balances. So if I hit solve and let me display then what happens when I do that, it gives me a table, a plot of concentration of A decreasing continuously with time, the concentration of B going through a maximum, and it shows the equations. And then it shows data that you could copy into, for example, a spreadsheet if you wanted to make a different formatted plot. And so very easy to solve differential equations using PolyMath, and if we have 5 or 10 reactions, the procedure is exactly the same. It's going to solve those equations simultaneously.